All right, guys, we're here at the InterMountain Logging Conference in Spokane, Washington. If you guys remember last year, it was my first ever public speaking event, was at this event right here. This year, they've invited me back to be the keynote speaker. So this video, we're gonna check out some cool logging equipment, and you're gonna see me nervous on stage in front of a couple hundred people. Wish me luck. Okay, forestry equipment is in a league of its own for being tough. Other than maybe mining equipment, I don't know what other equipment is used and abused as much as forestry, and I don't know any equipment tougher than forestry. Give you an example, what other machine puts 1/2 inch, maybe 3/4 inch Lexan plate with grade 8 bolts just to protect the lights? You have 1/2 inch Lexan grade 8 bolts to protect your work lights. It does not get tougher than forestry. Check out the size of the Grouser Pads on a piece of logging equipment. Like, that is skookum. If you compare this to construction, and this is a construction excavator, and you can see the size of the Grouser Pads that you have on construction. Like I said, everything in forestry is just a little bit bigger, a little bit more aggressive.
Yeah, my name's Frank Chandler. We're with Techno Forest Solutions. We import the product from New Zealand, winch assist traction line, and the interlock harvest line grapple yarder with the Hawkeye grapple carriage. So that's what we do. We import that stuff, and we're based out of Kelso, Washington, and market it here in North America.
So what do exactly these machines do?
So the winch assist, dual line winch assist traction line here, winches, we can winch skidders, feather bunchers, cutting machines, yarding machines up and down the slopes, construction machines, that sort of thing. So it helps these operator get around on steep slopes with minimal work.
Just get down a steep hill a little easier and a little safer. And
yep.
Little steeper hills.
Steeper and safer, yep. And then cutting wise, so we can cut these trees on steep slopes, put them in piles where generally they didn't have to be hand cut, and the yarding is more productive when these trees are in piles. So.
Okay, so you're cable yarding then, eh?
Yep, and we do a bit of cable yarding.
So what's the speed then compared relative to a skidding operation? Like, how does it compare when, because I've only worked for skidders, guys with skidders. Oh. So how does it actually work on the...
So grapple logging, I mean, is generally on ground that you're not going to get a skidder on. Even a skidder on a winch isn't going to work on 120% slopes. You know, a skidder's going to be limited on a winch line probably to about 60% slopes, I'd say. Maybe 70, depending on the soils, where the grapple yarder is floating over the carriage is floating over the ground.
It looked like he was going right across from one end of the canyon to the other.
Yeah. So the cable's suspended across the canyon, so we're just lowering the carriage. We're not trying to assist it up and down the slope. So.
Jeez, look at that.
Yeah. Mobile tail hold there. Because we're setting a few chokers. It's a Hawkeye grapple carriage.
So that's going to come down on the winches and on the lines.
Yep.
The grapple comes down.
Yep.
Lowers down.
Guy in the cab's got 3 cameras, so he's using the cameras to view where the trees are, where the turn is. That's camera view inside the cab. So he's just back and forth using that grapple to grab the stems off the hillside and bring them to the road.
What's the operating cost look like for an operation like this compared to just skidding on the ground? Is it?
Operating costs are probably double, if not more, depending on, it depends on, everything's getting more expensive. Skidders are more expensive, but I would say generally, operationally, production-wise, it's probably cable logging versus ground-based logging is probably at least double, depending on how far you're cable logging, could be 3 times more.
But it lets you get access to timber that you couldn't access
Correct.
Before,
100%.
Or was being heli logged?
Yeah. Access to timber that was you couldn't get before.
So how does that compare economically to helicopter logging then?
Well, it's way less than helicopter logging. Yeah, way less than helicopter logging.
Look at that! It's right across the whole canyon.
Yeah. Early grapple carriage there.
It's cool seeing what it looks like. More and more guys, or is that just a states thing, or is it just more and more people are going to this kind of setup with? Well,
grapple logging,
and...
the grapple logging is you can't get guys to set chokers anymore, and it's super dangerous. So winch assist, we brought that into winch assist cut because we're trying to get hand cutters is the most dangerous job. Get those guys out from under the tree and off the ground, and put them in the cab of these machines, and it's a safer job for them. And then same with grapple logging, we're getting the next most dangerous job in logging is setting the chokers. So we get those guys off the ground by just floating that grapple carriage over the ground and grabbing it with the grapple carriage and not having to set chokers with crew.
That's awesome.
Yeah.
Yeah. Look at the
So,
bank he is
we got the
heading
dual
off on there.
2-line winch machine there, so we're one of the only last 2-line systems out there. We kind of believe in that. It's live constant tension, so each line's tension independently from each drum.
So what's with the difference between the dual line versus single line?
Dual line is just, well, one is redundancy for going up the slope. You have a secondary stopping device, and then the dual line is dividing the loads. You're taking the loads, and we're all up here at this amount of load, but we're taking that load, cut it in half, so we're taking, and we're independently managing these loads so that if the load drops a little bit on this line, it's starting to pick up, but this line's still feeling the same tension. When you hook those 2 lines together, what the operator feels is absolutely nothing.
Oh.
So he's just like super comfortable, rock solid in there. He's not getting any slipping and moving. So
that makes sense, splitting the load in half. We were just
Yeah.
talking about that.
100%.
With our first truck, we had the one motor, one drive shaft, and it was snap and drive shafts because it was at its max capacity.
Yep.
By going to the electric axles, the motors are now split, and each axle now has
Sharing
half
the loads.
to share the load.
Yep.
Same thing with the dual line.
And you actually, what you gained with that was now you got traction on those tires that you independently that you didn't have before necessarily.
Exactly.
So you get other little benefits. So we got, with splitting the loads, we found that the operator's like, oh my gosh, now they're independently managed. So now what the operator, if a load changes a little bit, the operator doesn't feel it. And that's when you're on a steep slope and you get a little tension change, what happens is your tracks want to shift or move as you're swinging on the hill slope. Your tracks want to move, and it's like if your tracks move, you feel like you're going to tip.
Yeah.
And if you get a little bit of slack, you will tip. So 2 independent lines, live constant tension, you never get any slack. You don't fear of tipping, so you're just more productive. You just cut trees. Just go to work.
Smart. I like it.
It's cool. It's a good process. Yeah, I think it was some other.
Cool. Thanks for sharing this with us. I like that.
Thanks, guys. Appreciate it.
This is a Tiger Cat 920 dozer. Sorry, it's a TCI dozer. They're not allowed to call it a Tiger Cat if it's earth moving. You can only call forestry equipment Tiger Cat because of the name cat and infringement. So this is technically a TCI 920. This is a Tiger Cat 625H. This is used to take the logs from the buncher to the processor.
This isn't my first rodeo being the tallest man in the camera. Everybody wants you to squat down or...
Tajfun. All right, and we got a giant firewood maker, essentially, eh?
We do. This is our RCA 500. It does up to 4 cords an hour. 20-inch log is what it'll accept. And it's really our commercial unit designed to do 1,500 cords, 2,000 cords a year. It's really productive.
How big is a cord, roughly? I'm terrible at
A
this.
cord is 4 by 4 by 8.
So like a pickup box.
It's a pickup box, but like another, couple feet
A
on top
stacked
of
up
that.
pickup.
Yeah.
Okay, a
Yep.
fully loaded. Wow, that's a 2,000 of those.
That's like this parking lot full.
Yeah.
It's an enormous amount of firewood that guys are using. Very compact unit, but it's unbelievably productive.
For something this small, while we were watching it go through there, that stuff is just ripping.
Yeah, yep. So very easy to control. You saw everything's right here, one-handed, allows you to be able to keep an eye on what's happening. We use a 24-inch cannon bar on a 3/8 chain, so pretty common parts, but it's spinning just as fast as a chainsaw, 12,000 RPM, so that's one of the reasons you get those really fast cycle times. We get a wide variety of people. Landowners who want to produce firewood for them and their neighbors, commercial loggers who are tired of chipping wood or can't get good prices at the pulp mill, have taken to using this machine just so they can do something to utilize that wood.
I didn't think about that. Yeah, if you compare it to pulp, it's probably, you get a lot more for a cord of wood than you do with a pulp.
Yeah, exactly. And it's productive. People are using it to heat their homes.
So how much does a cord of wood go for these days?
On average, we travel all over. On average, I would say $300 a cord for just, pine, fir, basic wood. Some places do a little bit more if you've got madrone, maybe larch, I think pulls a little bit more.
We get so $300 a cord. This can do 2,000 cords a year. That's $600,000 a year in firewood this thing can make.
Yes.
Holy.
And you'll notice at a price tag of $74,000, it starts to make a lot of sense.
You can pay this thing off in like a month.
Yeah, you definitely have to have the outlet for that much wood. So I don't want to be unrealistic, but yes, it can be really productive if you've got a good source of wood, a great way of marketing it. This is your machine.
Well, that's basically like, I'm thinking logging trucks full of pulp, probably 10 trucks full of pulp. A load of pulp is, it's a lot more you get out of the firewood. That's a nice value added if you add it.
We've talked to a few guys who take this is our mobile unit, so they take it up to wherever they've got stuff decked. They'll leave it there, process some firewood, drive the truck down. So they're going up logging, and then on the way home, they're delivering a load of firewood. So they're basically making money coming and going, which sounds amazing to me. I really...
Basically loading up their pickup full of them at the end of the day and dropping it off.
Yep.
I mean, and you think about how, like, they're not super long, but you think about how much you leave behind in the slash pile, at least in Canada. You could probably just process up a slash pile pretty decent.
Yeah. Yep.
With all the, like, these are all the broken shit that you wouldn't put on a truck.
Yeah, exactly. But definitely burnable. You know, it's not hardwood, but, you know, it's, I hate to see it go to waste.
Yeah.
I like to burn firewood at my house. I do about 8 cords a year, and so I can't stand to see any of it get chipped or whatever. Like, it's
well, and people say that firewood's not good for the environment, but it gets burnt in a, if it's getting burnt in a slash pile out in the bush, or just left behind and burnt, or forest fires, well, you process it and you burn it hot in a stove where it burns more efficiently, it's actually better, and you're reducing the heat, because then you don't need to put natural gas heating or whatever heating. You can use a firewood to heat it.
Exactly. Yep.
Smart.
Yeah. Yeah. So like you were saying, these are, I think we do a max of 18-foot logs on here. So
oh wow.
Not gigantic, but
that's a little bigger
size.
than I thought, for sure.
Yeah. These ones are all a little bit shorter. The ones we had on earlier were pretty maxed out. We are a European company out of Slovenia. That's where everything's produced. You get a lot of that good European engineering. Not overdone, just the right amount. Lots of good technology and features, but they're sold all over the United States and Canada. So we have dealers in Newfoundland, Alberta, BC, all over the United States. You know, you can get on our website and have a dealer locator, or you can find me at the show and I'll tell you exactly where to get it, or you can come buy this one. I'll send you home with it.
Thank you.
Yeah.
Thanks for showing us some machine.
Yeah, you bet.
This is a Weiler B458 buncher. Main thing is this thing's got a giant spinning disc. That cuts a tree down. These claws grab the tree, takes down a couple trees, puts them together in a bunch. The skidder hauls it off. That's why it's called a feller buncher. It fells the trees, puts them into a bunch. Check out the actual size of these teeth. These things are a lot bigger than they look. Here we got a Cat D5 dozer. You'll notice on the forestry equipment, what's different than the construction equipment, full ROPS cage, full steel protecting the operator. These things just take a lot more abuse than they do in the construction side.
Hi there, I'm Dan Thurs. I'm a North American distributor for EcoForest T-Winch. They're a traction assist winch. Our small unit here is 11 ton full pulling traction, and then we have a larger one that's 18 ton. Very safe out here in the mountains. It is all run by remote control. So all you need is that remote control in your hand, nothing integrated inside any of the machines. So you can hook your pickup truck onto it, you can hook your dozer onto it, your skidder, feller buncher, anything. So it's super simple. So this machine, you would hook this on to any sort of machine on top of the mountain, and it would lower you down. This holds 1,650 feet of line. So if you were to cut with a feller buncher, you go down 1,650 feet, make your cut, come all the way back up, and this helps the machine get back up to the top of the mountain on steep slopes.
So you build these over in Austria then?
Yeah, we built them in Austria and in Slovakia.
Hopefully. Where do you sell them?
We sell them worldwide. Most machines we sold in Chile and also United States and New Zealand, Australia.
So how do you make sure then, if you're building these in Austria and you're selling them down in Chile and New Zealand, how do you deal with things like warranty claims and all that?
We just design it so they won't break, and over-engineer it and over-design it, and yeah.
Overbuild it, build it right.
Overbuild it, so we make sure that we, if the computer says you need 1 millimeter of steel, we take 3, and so that's how we do it. So
I like that. If you're gonna sell things, how do you mitigate your warranty claims? Just build a good product that doesn't break and don't have to worry about warranty.
yeah, of course. And then also have good dealers. If something breaks, then they can fix it. Right?
Awesome.
Yeah.
Well, thanks for showing us this machine.
Thanks. You're welcome.
Okay, so this is a kind of a cool challenge. I got a little excavator challenge where they're trying to put a ball in, and basically this is an event to watch grown men get owned by 13, 14-year-old boys. I've been watching the kids on this thing. They're wicked.
Oh, you nailed it. It's a timed event?
Timed event.
Your turn.
I'm not going. No way.
Here is the limmer head. Basically, once the skidder brings the logs to the processor, this thing comes around, these grapples grab the log, the big rollers move the log forward and back. This takes the limbs off, along with this part here, shears all the limbs, why it's called a limmer. And on the back, you got a saw that then bucks the log to the right length. Okay, you can't see the saw from the front, but what happens is that this arm drops down, cuts the log to length.
So I'm Mark with Hilltop Aerial. We manufacture heavy lift drones, primarily for cable logging.
How do you use these cable logging then?
Basically, we fly that orange rope, we fly it across the canyons and then use that to pull the haywire across. So typically what would take a man 3 to 5 days, we could do it in probably 10, 15 minutes now.
Because before, some poor guy's job was to pack that across the canyon, walk down the canyon with the rope, which I'm assuming is full of underbrush and all that shit.
Yeah.
You got to drag that rope through,
Yeah.
back to the other side. Now you just pick it up, fly it across the canyon with a drone, connect it, back to work.
Correct. And it's all straight, it's on tops of the trees, lines pick up straight.
This is the smartest thing I've ever seen for drones. I like that. That is...
We can pack power saws with these. We do have some in the fire rescue for water rescue.
Can you bring a guy his lunch?
Yep.
Yeah, how much can these things actually pack? You said a chainsaw.
We can pick about 40 pounds with them.
That's pretty good.
Yeah.
Wow.
I mean, you could pick heavier, but as far as being productive, about 40 pounds is your max.
That's a fair bit, though.
Yeah.
Wow.
We'll fly little blocks out, little straps to the rigging guys, so they don't have to carry them.
So you can fly this guy here out to a fella, right?
Yep.
I can only imagine if you got to pack that a few kilometers through the woods, or you just hike through the woods and have this bring it to you. Like, this is heavy. I know it never shows on the video, but that's solid steel.
Yeah.
Like, packing this through the woods would be
So we sell the big one for $33,000, and we sell the little 4-prop for $23,000. So yeah, we manufacture them. We also do a service, so if somebody wants a layout flown, we do that also. And you can find us. I think our website is hilltopaerial.com. And there's a lot of information on there if somebody was interested in looking us up.
I like you.
Thank you.
This is the limmer head on the processor. Basically what happens, these two arms, they come around the tree. These rollers come in, they move the tree up and down, and this saw cuts the tree to length. This machine here is a directional feller. It's kind of between a full-on feller buncher and a processor. Much like a processor, arms come around it, but this then cuts the tree down and then it lays it down in the direction you want it. This is a Komatsu 290 log loader. It loads logs. This is the part of the video where I act like an Instagram model and walk off all wonder of... This is cool, we're in a little simulator trailer.
Yeah, so I'm Robert Becker. I'm with the University of Idaho College of Natural Resources, and we recently received a grant through the Idaho Workforce Development Council, which really helped bring this vision to life of bringing simulators, logging equipment simulators, to our schools, to our current industry, to our future industries. How do we upstand and bring up our next generation of logging contractors in Idaho and beyond? And this is just a really great way to bring this to them. It's in a trailer, we can bring it to them. It's not dependent on having people come to us. And You can run fully off-grid with this. It has a generator on board, and we can simulate a whole array of logging equipment. As you can see here, it's been pretty busy all throughout the day, and some of these do have curriculum built in, training programs built in, and we're in the process of developing some additional trainings just to engage current workforce for professional development, for continual training, and just ways to get people ready to work in the woods. So it's not just outreach and education, it's real world training to get people's feet wet, to get them engaged and get them kind of exposed to it before you put them in a machine where the risks is higher, the cost is higher.
I think what we've learned from the excavator with the ball challenge and from in here is that kids are much better than I am at all of this.
And that's the thing is kids are so engaged with video games and doing this stuff. Everything's so mechanized in the logging industry anymore that they have an aptitude to do it that maybe some people don't, and they can pick it up a lot easier. So can we bring it to them, show them opportunities in the industry, and get them engaged in it early on? And like you can match these to what the machines actually do in the woods.
So he can go out, you're ready to go to work tomorrow then, eh? This kid is seriously good though. All right, well, thanks for having me back, eh? I guess a fan made a little voiceover to make us an ad like 2-3 days ago, so I figured we'd just play the ad because it kind of describes what we're doing. If you want to.
Edison Motors, a Canadian clean technology company that manufactures electric semi-trucks, and they're tough. Their L500 tandem packs a whopping 670 horsepower with an electric drive motor that puts out 68,000 foot-pounds of torque. Backed with a 450 horsepower cat motor, these are the toughest electric hybrid semi-trucks on the market. Check their website at edisonmotors.ca for their full selection of tandem and tri-drive units, or consider a retrofit kit. Built for truckers, by truckers. Edison Motors.
Right on. Well, that pretty well sums it up. So I think we're good to go. Now, we put together a little presentation about 30 minutes before lunch, because I'll be honest, I didn't know what I was going to talk about when I got up here today. So me and Theron sat down and made a quick slideshow, and I figured I'd go over a little bit about the technology, but mainly kind of focus on just how a bunch of loggers in Canada built an electric truck and how we managed to do it. When you think about it, there's billion-dollar companies spending all of this money on R&D to build these electric vehicles. Like Freightliner e-Cascadia, $1.2 billion, $4 billion on the Tesla Semi, and every single trucker says, well, that's not gonna work for me. So how come when all these big corporations are spending billions, a bunch of Jippo loggers in Canada were able to build an electric vehicle in a tent? And I just figured we'd go through that process and how loggers kind of got it done. Is this like a clicker for this slide? I can build a truck, but I can't figure out how to use basic technology. Oh. Yeah. Oh, I'm holding it upside down. So we started out a trucking company about 10 years ago now, me and my buddy Eric. I put myself through university by driving truck. Finished university and realized that, man, the jobs sure suck out of university. I drove logging truck before, fell in love with logging. I said, well, I can make good money going back logging. So we put together what was left of our student loans and we bought this truck, 1969 LW for $4,000. Truck and trailer. We spent the last semester at university, we fixed it up, put it on some long logging rigging on it. We went to go work hauling logs, bought another truck, and kind of grew it a little bit. Got into some low bedding with the old girl, and that low bedding led us into hauling generators. When during breakup, we needed to haul other equipment, so we started hauling equipment for CAT. Then we started hauling generators. And then we realized you could make a lot more money if you did the install on the generators than just trucking the generators, and how hard it is to hook up a diesel motor and get an electrician to come out and plug it in. So where it really started was this project right here. This is where our whole idea from Edison really happened. This is a small little First Nations community, about 40, 50 people, way up by the Yukon border. In this community, they were running 100% off diesel. They had an old worn out Deutz generator, needed to swap it out. They wanted to swap it to a 95 kilowatt hour unit. And we thought, that's a lot of power for a real small community. 95, let's look at the power usage. And Eric, who's a lot smarter than me, had a look at that power demand. And what they found is that there was a huge peak power demand. Everyone would get home from work around 4 or 5 o'clock, turn all the lights, all the power on. And it would spike to 70. So the 95 kilowatt was just to be a little bit of extra and meet that 70 peak load demand. Their average load demand was only 20 kilowatts. So what we did is we went into this little building there and we put a large battery bank. The battery bank met the peak load demand. We put in the solar panels for the summertime, and then we downsized it from a 95 to a 35 kilowatt hour generator. The system with the hybrid cost about $50,000 more, but this community saved about $80,000 in fuel their first year of operation by just optimizing it with the battery meeting the peak load demand. And that's when we were kind of looking at electric trucks, and we said, well, why don't we do a truck the same way? A truck is really, really similar. Huge peak power demand to get it moving. When you're climbing a hill, you're full on the throttle, but once you're just cruising down the highway, you're backed right out of it. You're really using 40% engine power once you're cruising. It's just for starting, stopping, climbing. You have the regen braking. So we thought, well, I like the batteries. I like the electric motor. Batteries aren't enough, so we'll, instead of having a big 15-liter diesel, we downsized it to a little 9-liter diesel. And that's basically how our drivetrain, we came up with this. It was modeled after it. We put some batteries in the frame rail. We put electric motors on the back, and that cat under the hood just exists as a generator. And that idea led us to our very first truck here. This is the one I presented last year, talked about, showed some videos. Last year, we finished this guy off. We took it out, we did some testing, and what we found is, yeah, you get a lot more power, a lot more fuel. There was a few things wrong with this, though. We had a center-mounted motor, it went to a drive shaft, it kept snapping U-joints, the electric power was just too much, constantly blowing out U-joints, so we made some design changes, and we came out with our next truck. So the basic fundamentals, it works like a freight train, or if you guys know the old Laterno log loaders, those things were all diesel electric. They work pretty well the same as our truck. So once I left here, we started and we had an idea. We let the internet design a truck because we were making fun of Tesla. Tesla has that center-seated cab, and I'm like, a center-seated cab's just a skidder. Put a skidder on a truck. And we're like, oh shit, how do we build this thing? So we did some 3D renders. We put it in a video game so we could play around a little bit, and that's about as far as we were at the last login show. Last year when I was here, this is what we had in the shop. Just a bare set of frame rails. Then we had to go to the electric axles, take those frame rails. We shipped in our electric axles that we designed. This is basically how it works. It's a standard differential with an electric motor hopped onto the front. Took those, we put them on some Hendrickson walking beam rubber blocks because that was easy to install. And it's a prototype, so nothing shakes apart a truck better than an old walking beam. Mounted those, put it in there. We designed the whole truck out of a bunch of plywood because we didn't have a bunch of fancy computer engineers to figure it all out. So we just scaped her out of plywood, grabbed some angle iron, welded it up, took the old backhoe, put the cab on, kind of played around with how it went. Like, we literally just grabbed steering linkages, started putting it in the cab. How does this thing fit together? Took the cab off once it worked. We started installing our wiring, put the cab on, put the hood on, dropped our headache rack. That's the entire power distribution unit that controls everything with the power inverters, contactors, safety equipment. We just figured, well, easy to put it in a headache rack, and then if we got to do a retrofit and do another truck, well, we can just take a roll of truck in, swap the axles, put the batteries into the frame rails, put the generator on, drop the headache rack on. That is the generator. So instead of a transmission, that's a generator you got. Got it all wired up. Those are the batteries that you see between the frame rail, and that is the first time. So it sounds really easy. Just put the batteries in. We probably spent about a month, 2 months playing around with the programming. That was this summer. We were able to get it down to the fully charged show last September where we debuted it. That's my mom. We called the truck Topsy. The reason why we named it Topsy was, well, we're called Edison Motors, and Topsy was the name of the elephant that Thomas Edison electrocuted. So I thought that would be funny. Then we finished the show. We sent it off to Ontario to go through all the government testing that you got to go through when you're building the truck. And our first ever load as part of that testing, we hauled this World War II Sherman tank. It was actually an old Medill yarder, and the yarder was no good. They weren't using it anymore, so Buddy took the top of the yarder off and put a 1980s Chevy square body, and you can drive the yarder around from the Chevy. Not relevant at all. It's just really cool. So we figured that would be a first load, and our total weight was about 100,000 pounds, 105,000 pounds. So on our very first load, we already hauled 100,000 pounds more than any other manufacturer's electric truck. Everybody else hauls 80,000 pounds max. They're focused on the highway. We weren't. We wanted to build a truck. Logging trucks pack a little more weight. So we did all that. We did all the testing. Thanks, Darren. We literally made this slide a while ago. So we finished it. We got our license plate. We got our VIN number, which was cool because this is the first semi-truck built and produced in BC since Western Star shut their plant down in the 1990s. Literally, they're like, wow, we have not issued a commercial truck VIN number in 30 years. They had to dig out how to actually issue it through the BC government. But we did it. It was a mountain of paperwork. I cannot emphasize that enough, how much that sucked. But we got our license plate on it, and now we're just at the point where we're starting our road testing, which is pretty exciting. And while we're doing that, and it's going through its testing, we started a couple other projects. So we realized that that same technology that's in the semi-truck there, it's an axle swap. It has 6 batteries. It's got electric axles, and it's got a little generator. Well, we can take the exact same batteries and put them into a pickup truck. Instead of having 6 batteries, it's got 2 batteries. Instead of 5 inverters, it's got 2 inverters. So everyone kept asking for pickup trucks, service trucks. So we're in the middle of putting the new motor into a 1945 International. It actually has a World War II VIN number registration on it. We're also doing up a couple service trucks. We've got 8 trucks on the go right now that we're building, and we're taking over the old Hayes truck shop up in Terrace, hopefully, where they used to make the HDXs for up in Haida Gwaii, Queen Charlotte Islands and all that. And we got to build a couple more trucks for a few customers, but that's basically where we're at. With all our testing, we showed that for fuel savings and all that, logging operations in BC, where you're uphill, downhill, 50, 70% reduction in fuel. By going to a generator that's running at 1 RPM, you can literally reduce the fuel bill by half. We did find, though, that on highway hauling, you may have 0 to 10% fuel savings. It's really not. This technology of hybrid has its place. It's not for the long haul. Yes, it has batteries it can put in, but you can gear a manual transmission to work really well where you get up to speed with 80,000 pounds, you stay at 160 mile an hour and you stay there for 3 hours. Well, you can gear that thing to run really efficiently. You can't gear a logging truck or a snow plow or a concrete truck in the city because every time you're starting up, you're slowing down, you're going through the gears, you mash onto the throttle, you wait for the turbo to spool, you just get some torque and then you shift another gear, you lose your boost. That's where the electric comes in. It's peak power demand. The batteries shove you off the line. It meets that peak power demand. It gives you the thing. In the city, for just city driving, we're showing 30 to 50% reduction in fuel. Logging is by far the best application. You're going uphill empty, coming downhill loaded, but really what we found here is, well, we designed it. As loggers, we designed a logging truck, and then other companies like snowplow companies, concrete mixer companies have been reaching out to us over the last year and saying like, hey, what about a hydrovac? What about a concrete truck? You can run fully electric when you're going into a residential area, unload on electric, go completely quiet, and then head back, fire up the engine on the way back to the batching plant. So that's kind of what we found in the testing. Now we're going to get into some more heavy real world testing, and we'll see how that goes over the next 6-7 months. So just wondering if you got any questions on this. Yeah.
How about winter with the cold? You guys get the cold like we do. That affects you?
Yeah, the cold definitely suffers the range a little bit. You do take kilowatts of power to run the heaters. The cab's got a bunch of electric heaters in it, electric air conditioning unit, and you got to keep the batteries warm. So lithium batteries, unlike lead acid batteries, they're not negatively affected by the cold. They'll still discharge totally fine in the cold, but if it gets below 0 degrees or 32 Fahrenheit, below freezing. Once you get below freezing, they won't take a charge, which means that if you try and regen the brakes, the batteries have nowhere for the power to go, so you can't have your regen in the cold. So the batteries have a heat grid in them. Those heat grids keep the batteries warm, and then it's got liquid cooling for the summertime. In the wintertime, we heat that glycol, and the batteries are heated with the glycol, and the thing but you do suffer decreased range. So it means that you got to fire up your generator a little bit more. You're going to be producing a little bit more fuel, but anyone that runs a truck in the wintertime just knows that, yeah, in the wintertime, trucks burn more fuel. There's a little bit extra just because of the battery heating, but it's not terrible. Yeah. Oh, it kicks ass. That thing is, you guys, like, you ever driven a Tesla, like, or electric car where you have the regen? It hits hard. It's, so on a normal Jake, you get about 40 to 60% of your output power on the Jake. Just, it's not as powerful holding back as it is going forward. The way an AC motor works is that an AC generator and an AC motor are basically the exact same thing. So you can hold back with 100% of the power that you're holding forward with. Now, there's a little bit of limitation in the inverters, but yeah, the regen is much stronger than a normal Jake, which we had some interesting conversations with some licensees and logging companies, and we designed this, and you're like, oh, it's going to be a lot easier on the driver. You're going to be able to get up the hill a little bit quicker. You'll be able to hold back quicker. And then we started talking to the customers who own the truck, and then all of a sudden, oh, well, we can make a steeper adverse in the block, or, oh, I guess we can run down a little. Well, what if we put some electric axles on the trailer with some hold back? Then you can really come down. And, you know, we were heli logging those blocks, but I bet we could get a spur in there. We run the center tire inflator. We really get the power. And I'm like, oh, we have made life harder for the truck driver. That was, they're just going to send them up steeper blocks. Oops. Any other questions? Oh, yeah. The DC, the problem that doesn't work is that the DC motors, you can't do the regen. So you can't get the hold back, which means you'd just be constantly on the brakes. That's the biggest thing. It would be more efficient because we have to take AC motor from the generator, change it over to DC, charge the batteries, and then take it from DC. So we have to have an extra couple inverters. In the case of the truck, it's 2 inverters each way on the semi-truck, 1 on the pickup. But rough cost about it is about, that's always a question we get. Depending on how you spec it, it works out to about 20% more, 30% more than a normal truck, which, so we're around that 400,000, 450,000 Canadian range. So like $50 US or something like that, I don't know. I'm not good at doing the math, but if we figure that out, it's relatively a little bit more comparable to what you're getting with like a fully spec'd out W9. But your fuel savings sure help make those payments when your fuel bill up, and oh geez, we just have a new carbon tax in Canada, so now we're like $2.30 a liter, which is something like $8 a gallon we're paying for diesel now. The fuel savings make a big difference, and also it kind of shows you how the new truck manufacturers are kind of screwing us over there. I probably shouldn't say that, but like, if we were able to build this in a tent in my parents' backyard and be able to deliver a truck for $450,000, how is a brand new W900 Kenworth coming right off the assembly line $350,000, $400,000 now? You shouldn't be able to hand-build a prototype electric truck in your backyard for the same price as basically what they're rolling out on an assembly line with plastic parts. Like, everything on this truck was made of steel. Old school gauges, old school metal dash, metal columns. They're trying to say that everything's gone plastic because it's going to make it cheaper. Well, how come it's way cheaper for us to build it all out of steel by hand than it is for plastic on the new part? Like, I don't know. Maybe it's because we don't have $1,800 headlights and $500 turn signals, but at what point? Like, come on, guys. Sorry, that's a bit of a rant, but like, yeah. The weight on this one, the one on the left there comes in around 22,000 pounds. She's heavy, but we built her like an old Pacific P12. It's probably absolutely overkill to use like 1/4-inch metal, sheet metal for the fenders. Not even sheet metal at that point, that's just plate steel. What we found though on that truck on the right, the 1962, the weight when we started was 9,000 kgs. When we finished the retrofit kit, the weight was 8,800. So we lost 400 kgs, about 400 pounds weight reduction. Reason why it's actually a little bit lighter is instead of having a 15 liter, and engine, you now have a 9-liter engine. You knock off about 2,000 pounds of weight. The generator weighs a little bit less than a manual transmission or automatic transmission does. The reduction in weight is, yeah, about that 2,000 pounds. The batteries weigh 600 pounds. There's a little bit of added weight for some of the wires and some of the inverters, but all in all, it kind of balances out where the weight's the same just because you're reducing the size of one thing while increasing the size of the other thing.
Well, are you going to keep building them in the backyard, or are you going to build a plant?
Oh, no, that's why we got that, that shop and terrace for... No, we're still waiting on the city to approve a frickin' zoning permit. Like, it was literally where they used to build the Hayes HDXs. And then for some, in their infinite wisdom, the city's like, you know what? I know that's a giant commercial building with overhead crane, or industrial building. How about we zone that commercial? That should probably be a coffee shop or something. And it sat unused for 20 years. And now the city's like, well, okay, you could buy it, but like we would have to change the zoning because why would anybody else use this for anything other than a coffee shop? I don't know. City government.
A timetable for the next 2 to 5 years on when you might get this out the door to be a sellable item?
Yeah, so we've actually sold our first 8 trucks. We brought out a bunch of customers, took them out for a few test drives, let them see the truck, see the performance, and they basically said that, yeah, they were happy with it. If we can get a VIN number and get Transport Canada to approve it, which we did, they'd be happy too. So we sold 1 retrofit, 3 brand new of our new builds, and then we're doing 4 of those pickup trucks. That World War II International, a service truck, a new Dodge, and another slightly less new Dodge.
How much is the retrofit going to cost?
Oh, it depends on how you want to do it. So right now, the first kits that we got to order, we're looking at like $70,000 because we're only ordering enough kits to do 8. On our supplier agreements, if we can order over 100 kits at one time, and once we get her figured out, the price for the pickup truck retrofit is going to go down around that $30,000, $40,000 range. But I hate giving quotes on that because inflation has just been really, really stupid. Some of our parts since we started 2 years ago have tripled in price. Other parts have come down in half. Like their battery cost, we used to be paying, when we built the very first blue truck, we were paying $450 per kilowatt hour for the batteries. Now today, when we just ordered our ones for the last truck, we're now paying $150 per kilowatt hour. And they're expecting by the time next year, it's going to be down to $100. So we knocked down the truck battery on a pickup truck going from $30,000 for the battery, or no, yeah, $30,000. We've now knocked the battery cost down to $10,000. And that was one of the most significant cost of the whole kit. So I really can't tell you the cost. Some things might go up, some things might go down, but you're in that ballpark $30,000, $50,000 range. You really want to get super fancy, you could get up to 70, but the semi-truck retrofit is harder to predict because there's so many variables on that, and this is the stupidest thing that I think is insane. It's cheaper for me to build a brand new truck for somebody because the government will give you a $150,000 incentive on a brand new electric vehicle. Perfect, you want a new electric vehicle? Government of Canada, here's $150,000, glad you bought a new truck, and you're like, hey, what about taking an old truck? It's got a motor, it's looking at it needs a whole reframe, in-frame done, new rear ends. This truck's got good bones, good frame rail, good cab. Can I just electrify it? And they say, well, that doesn't apply to the incentive. The incentive is only if you throw that out and then just completely rebuild something new. Because it's way better for the environment if you just keep throwing shit out and building new shit. So why would the incentives apply to a retrofit? So it's harder to sell the retrofit on the semi-truck side just because you're like, yeah, I guess I can get a whole brand new everything for less money. Thanks, Trudeau.
How are you paying? Do you have investors, or how are you funding all this?
YouTube. Oh, it's as insane as that is. We get a lot of money off of YouTube revenue. But we did a round of crowdfunding. So when we first came up with the idea, I'm like, yeah, $50 buys you a hat and 50 shares in the company if you want to try and fund this. And that's when it kind of exploded. Like I was still driving a logging truck, and all of a sudden within 4 days, we had raised $450,000 in just selling some hats. And we're like, oh, Like I explained what the idea was. I'm like, that's insane. So like, I guess it's time to do this. I looked at my business partner, Eric, and like, do we just go for it? Like at the time, it could have been like, we had no idea. Like we were insane. A bunch of loggers trying to do what billion-dollar companies couldn't do. The odds of us doing it pulling it off weren't high. Everyone told us it wasn't, but once we raised that 450,000 in 4 or 5 days, we had enough people that we thought were behind us believing in the idea that we thought, well, let's quit logging. We're not going to drive anymore, and we're going to do this full time. And we built that truck within a year. We released Topsy. We did another round of crowdfunding, and we raised $1.5 million in 4 days. And we've been going off that $1.5 million for the last year and a half. We've just been very frugal. Like I say, I still live in my parents' basement because I'm not putting the money towards a shop. I'm not selling trucks. We're not making money. Too many EV companies. It was just in the news, like Canoe that's building that electric bus. Their CEO's private jet cost twice as much as all the revenue from the company put together. Like, it's insane. Like, we did this on $1.5 million, not $100 million, because I don't have a private jet. We drive a $4,000 Ritchie Brothers special pickup truck that probably needs a thing. Like, you can go a long way if you kind of just act like a Jippo logger and just kind of make shit happen.
What do you think your limiting factor is to keep producing this and go bigger?
Well, probably shop space, getting the trucks out there, and it's just time. You got to get the trucks out there. You got to prove them. You got to make sure it works. We built a couple. Now we're going to build 8. We're going to make sure that these 8 are really solid. Then maybe we do 20. Then maybe we do 50. Then once we're happy and you got 100 trucks on the road, then you can start looking at, okay, well, what happens if we build 200 a year, 400 a year? Way too many companies in this EV space, they try and say like, well, you look at Nikola or Tesla. Within 2 years, we're going to be building 20,000 trucks a year, 50,000 trucks a year. All we've done is build one prototype. Then they send the trucks out. The trucks have problems, and they got 400 trucks that they got to recall. Well, time is really the limiting factor. It just takes time to test it. It takes time to make a good product, and we've got the people interested in the sales. We just got to keep building and keep going along with it. And yeah, maybe if we had a little bit more investor money, it'd be easier, but we kind of told a bunch of venture capital guys to fuck off because they were just absolutely, well, they wanted to put so many executives in there. They're like, hey, we would love to invest 10 million. We're like, awesome, that would really let us hit the throttle. And they're like, okay, well, we're going to need to, you need a new COO, you need a CFO, you need CPAs, a bunch of C-suite guys that we're going to make $300,000 a year. Well, that's 10 guys at $300,000 a year. That's $3 million a year out of the $10 million just on executives. Not one of them, we've talked to 10, 15 different venture capital guys. Not one guy they suggested had any background in trucking, logging, nothing to do with a vocational truck. Some of them are like medical devices or just technology and I write software. Like, well, why would it help me in production to have 10, 15 different executives sitting on the thing? Like, it doesn't make the mechanics work harder. Like, it doesn't matter how many Gantt charts you make, the mechanics in the shop aren't going to work any harder. The truck isn't going to be able to pack more weight because you have more executives. And I don't know, might not have been politically correct, but I told them, like, this is stupid. This is how every EV company spends way too much money. How about we've gone down the route. I think we can all admit that we have seen so many companies go down the route of Silicon Valley, tech bros with the newest, latest, greatest idea that raise hundreds of millions or billions of dollars in capital money and have no clue on how shit actually gets built or how the country was built. This country was built, wasn't by guys in suits sitting down in an office at a computer. It was built by mechanics, built by trades guys, built by like the people in this room are what build the country. We told the venture capital guys to fucking do one and we'll build their truck our own way. If it takes a little longer, it takes a little longer, but at least it'll get built. Yeah.
Did you ever find any fuel for Frank's road grader?
Yeah, we bought Frank a couple cases in Milwaukee and he finally got it. Oh, he was so mad I made that video. Frank is a real guy. He was just genuinely annoyed. It's on the YouTube. So the battery life, they come with a 7-year warranty, 8-year warranty on the batteries. And what happens is that at year 10, they figure it's about 50% if you were running it as a full BEV, which you're just depleting it all the way down to 0 and building it back up. The way we programmed our generator is that it only keeps those batteries between 80 to 50%. Talking to our suppliers, they figure we can get about 15 years because what we're doing is we're just topping them up to 80, we're bringing them down to 50, we're keeping them in the efficient operating range. And then even in 15 years, now on the semi-truck, yeah, that's about $30,000, $40,000 to replace your batteries, which is basically equivalent to doing an in-frame in 15 years. The other thing though is that you may not have to, we don't know for sure because it hasn't been tested long enough, but what happens is that the batteries lose capacity. So right now, driving a truck off the batteries it got, so you get about 2 hours of driving and you about 30 to 40 minutes if you're parked recharging the batteries. What may happen if your batteries go down to 50% capacity, instead of 2 hours of driving, you now get 1 hour of driving off your batteries, and then instead of an hour of recharging, you get 30 minutes recharging. So it just kind of shorter duration charge cycles. What would happen though is your peak power demand would go down. So instead of having 800 horsepower, you're going to start limiting to 400 horsepower, and it's 500 horsepower, and it's going to start getting annoying for the driver. But at least the one thing is that, yeah, it's equivalent in cost to doing an in-frame, but at least you can see it happening long-term. So you'll be able to save up. It can be a planned thing. You'd be like, okay, the truck's performance is degrading. The batteries are getting lower. My generator's firing up more frequently. I should probably look at switching these batteries out in the next 4 or 5 months, and breakup is 2-3 months away. Maybe I'll just do it in breakup. And I think like the hybrid makes a lot more sense. I don't know why we're the only company doing hybrid, why we're the only company. They all want to focus on pure battery electric. They want to focus on highway hauling. And it doesn't seem like the big OEMs really care about the loggers or the vocational or the city guys anymore. Yeah, so you could theoretically fully recharge the battery going down the hill. It depends how heavy you are, how steep the hill is, how long the hill is. But when you're going downhill, the electric motors recharge the battery so you don't have to fire up the generator. So theoretically, if you have the right haul, say you're hauling somewhere on the coast where you're just tripping bunks into the water, you come down the mountain, you start at the top of the hill with almost 0%, you build your battery back up to 100%, you drive 30 minutes to where you're unloading, you go all the way back up empty on electric on the battery, you reload the logs, you go back down, you rebuild your battery. Theoretically, you could run the truck indefinite. There's actually a few trucks operating in Norway that are full electric on this principle. They're using it for a mine haul. They got the iron ore up at the mine up at the top, and they got their crushing plant down at the bottom, and they produce power going down, then they go back up empty, and they've had these vehicles operating, I think now for 2 years, and they've never had to recharge the batteries. They're just infinite energy using the stored potential energy of the logs up, or the ore up at the top of the hill and going down.
So what's the logistics selling these in the United States?
I got to go through FMVSS. So I went through like the CMVSS, but I got to go through the American side of things, and that's going to be about another $800,000 to go through that program to get the truck certified here. So it's going to get to the point where we'll have to raise a little bit of investment money, take our truck, bring it down to the testing facilities down here, and go through a 6-8 month testing. It's just, we'll get there. Hopefully next year is when we're looking at doing that. All right. Thanks, guys. You want to see more? We're on YouTube. Thanks.
Hey, Chance, thanks a lot for coming down and speaking with us.
Thank
again.
you.
Don't go away yet.
Okay, okay.
We give some people the boot, but you're so good a speaker, we're going to give you an X.
Wow, that is going in the other. Thank you. That is. Thanks. Oh, yeah, right.